Okay, so let's pick up on 33. Marty is spending money at an average rate of $3 a day. It's a slope, you guys. It's a slope. Marty's spending money at an average rate of $3 a day. Ooh, when I did this problem earlier, I forgot to put that as negative. He's spending. He's taking something away. After 14 days, he has $68 left. Days is going to be independent. Days comes before money spent. I have a point and a slope. I have a point, the 1468, and I have a slope, his rate of change. So I go to y minus 68 equals m x minus 14. So y minus 68 equals negative 3x minus 14. I think this equation is a lot more useful, especially since what's going on next, how much money did he begin with? If I distribute and simplify this down to slope-intercept form, 3x, negative 3x plus 42. If I simplify this down to slope-intercept form, I'm going to find out where we started. If I add 68 to both sides, y is equal to negative 3x plus 100. How much money did he start with? $100. Taking away $3 every day. Now in number 34, we have this cricket chirps. We messed around with this in one of the problems I think that we did as a group. Biologists have found that temperature and chirps are related. What we discussed is that temperature would be our x value and the number of chirps would be our y value. Chirps. And if you read through the problem, we find out that we have two ordered pairs. 68 degrees resulted in 124 chirps. And at 80 degrees, it resulted in 172 chirps. And so we have 2 points. Probably the best equation to go to is point slope. Let's find the slope. Difference in y values divided by difference in x values. And does anybody have what that is? Let me do it real quick. 172. You guys, somebody does something. 48 over 12. So the slope is 4. So the slope is 4. Now that's all fine and dandy, but I have to finish writing this equation. And what I'm going to do to finish writing this equation is I'm going to pick up and use point slope form, and I'm going to just snag this point and this slope. It doesn't matter which point you use. In the end, we should have the same thing. Y minus 172 equals 4. I'll get back to this 150. I need an equation to be able to get back to it. Equals 4 times x minus 80. If I go through and distribute this all out for x minus 320, if I take my 320 and add the 172 to both sides, I find, nope, it's negative 320. I find out that y is equal to 4x minus 148. So there's my equation. And then to find out what the temperature is, if the crickets are chirping 150 times, I put 150 in for y and solve it for x. If I add 148 to both sides, that's going to take me up to 298 equals 4x. And 298 divided by 4 is going to tell me that the temperature is about 74.5 degrees. 74.5 degrees. Mark, I'll come back to your question. I want to move on for the video, okay? Number 35. Direct variation. Let me throw a quick little reminder about direct variation in here. Now, in direct variation, I don't want you guys to be real confused about this. This is y equals ax. Now, a is slope. A is slope. This is just a fancy setup for when our y-intercept is 0. I feel like this is one of the simpler concepts that we've had, but you're playing like it's maybe more difficult than it needs to be. So I'm going to say this right now. If I needed to, I'm going to put a couple things on here to help us with 35. If I know an x and a y, and I want to figure out slope, I would divide both sides by x, wouldn't I? So in a direct variation equation, your a, or your slope, is just equal to y divided by x. In a direct variation equation, your slope is equal to y divided by x. So if that's the case, then in a problem like number 35, bricks in minutes, laying bricks and dealing with it in how many minutes? I'm going to say minutes is going to be our X. The amount of time I have is going to determine how many bricks that I can lay. And so I think one of the big things is just stopping and going, what's the independent-dependent relationship? Minutes is independent, bricks depends on time. And what I find out is that, okay, my slope, what's my rate? So my rate of my slope is going to be the number of bricks divided by how long it took. 45 over 65, I think, reduces to 9/13. 5, I think it is, and I'm going to, math crack would reduce that down for us. So the equation is y equals 9/13 x. That's it. How are they related? I feel like this direct variation has gotten to be kind of a big, confusing problem, and I want to put it back in a little neat, easy package. Now, determine the time it would take to lay 500 bricks. Well, 500 is equal to 9/13 times what time? So I'm going to multiply 500 by 13/9. The reciprocal on both sides. So if I multiply by 13/9 on both sides, I'm going to find out that the time it takes is 722.2 minutes. And for our sake right now, I'm going to leave it right at that. I can figure out how many hours, because I'm definitely not counting how many minutes. I'm working on counting hours. But for right now, I'm going to leave it sitting there. Now moving to 36. The number of gallons of fuel used on a trip varies directly with the number of miles traveled. Gallons of fuel varies directly with miles traveled. What comes first? What's independent? What's dependent? What do you have to have first? Gas. So gallons of gas is going to be my X, and the miles I can drive is going to be my Y. And if that's the case, then let's just think about this as our slope is just how many miles in 12 gallons, and that's going to give us that slope, that rate. Y divided by X gives me my slope. So 270 divided by 12, my slope or my rate is 22 and a half. I should have actually used M and G, shouldn't I? Miles equals 22.5 times gallons. Pretty good gas mileage, actually. Miles equals 22.5 times gallons. So then my question to answer here is, if I've got 400 miles to go, how many gallons of gas is that going to take? So 400 divided by my 22.5, I need 17.7 repeating gallons. I better be putting 18 gallons in my tank so I'm not showing up on fumes. Now,